26. How many structural isomers have the molecular formula C4H9Br? So what you've got is you've got butane, or you could shorten the chain. Butane to start off with, let's say with a Br. So where could the Br be on butane? It could be at carbon number 1, or it could be at carbon number 2 to make 1-bromobutane or 2-bromobutane. 3-bromobutane is the same as 2-bromobutane, just labelled from the other end, and 4-bromobutane is the same as 1-bromobutane, just labelled from the other end. So I've got 2 from a butane chain. I could shorten the chain to be 3, and I could have methyl propane, and then the Br could be at carbon number 1 or carbon number 2, so that's 2 more. So there's 4 in total. If it was if the Br was on carbon number 3 of methyl propane, it would be the same as 1 methyl propane. So I can have 1-bromobutane, 2-bromobutane, 1-bromomethyl propane, and 2-bromomethyl propane. The chain can't get any shorter than that, shorter than 3 with a branch. So my answer is C. What's the major product of the reaction between but1ene and dBr? Well, D is representing a different kind of hydrogen. So if you imagine D is HBr and you've got but1ene, so you've got the carbon-to-carbon double bond between carbons number 1 and carbon number 2. Let's imagine it was HBr for a start. The H would go on to carbon number 1 and leave a secondary carbocation, which is more stable, and the Br then would join on to carbon number 2. If the H went on to carbon number 2, it would leave a primary carbocation, which would be less stable. So the major product has the H adding on to carbon number 1 of the but1ene. The carbon-to-carbon double bond is between carbon number 1 and carbon number 2, and so the H will go on to carbon number 1, leave a plus charge, a secondary carbocation with a plus charge on carbon number 2, and the Br minus will use its lone pair of electrons to then react with that C plus carbocation and form the Br on carbon number 2 in a process called electrophilic addition. So I'm looking for the D on carbon number 1, which represents the hydrogen, and the Br on carbon number 2. That's the D on carbon number 1, the carbon on number 4, the D on carbon number 1, and the Br on number 3. Here, it's labelling from the other end, but the D is on carbon number 1 and the Br is on carbon number 2. So C is looking good. Let's just check D. Yes, D is the other way around. That's the minor product, where the Br is on carbon number 1 and the D is on carbon number 2. So your answer is C.